Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. This is the project of IoT based weather forecasting and alerting system done by engineer Shahzeb Awan and engineer Shahriyar Alam Khan. Application area of the project. At the top of the line, I have written down the meteorological data unit of artillery. Artillery and other armored units need the environmental data to compute different trajectories. Similarly, for alerting system and weather forecasting, home automation and trend analysis, we use these type of sensors and these IoT based applications. Moving towards the overview of the project, this is an IoT based weather alerting system. In this system, I have used a sensor that is called BME280 that is computing pressure, temperature, and humidity values. Raspberry Pi 4 has been used to send this data to the cloud. The cloud platform is ThingSpeak. ThingSpeak is an open source cloud platform that has a built-in Matlab support, so you can rely on Raspberry Pi or any other device to compute some important data or heavy data. You can do it in the Matlab that is built in the ThingSpeak. So I've just built in a small check value that if my threshold value of the average humidity is increased from 60 percentage, then a specific LED will light up. That's the block diagram of my project. The Raspberry Pi 4 has been in the center, reading the sensor values from the BME280 and transmitting those values to ThingSpeak cloud. And I am retrieving some resultant average value of the humidity for checking that whether the value is achieving a threshold or not. If the value is greater than 60, alert LED will light up, and if it's less than 60, a safe LED that has green in color lights up. That's the demo video.
So that's the complete setup of Raspberry Pi based IoT weather alerting system, in which I have used a Raspberry Pi as a system on board for sending the data to the cloud. The cloud I'm using is ThingSpeak. That's the Python code, and I've used the I2C based sensor, that's BME280, for measuring temperature, humidity, and pressure values. Two LEDs are being used here. One is red and the other is green for indicating if the value 60, then light up. You can see now the values are in 47 average humidity values, and it's considered as safe. 58.
And now you can see that red LED lights up.
So that's
Now moving towards the cloud interface, I've also made this video and you will see that how cloud interfaces with this thing system. Now I'll show you how my Raspberry Pi sends the data to ThingSpeak channels. These are my cloud channels. Two channels have been there. The first channel is named by Shahzeb and it is receiving my data from the Raspberry Pi. And the second channel is the resultant channel. Let's see this channel. In the first channel, I'm sending the data of humidity, pressure, and temperature. And these plots, so you can see the values have been updated. Now, I will show you how the backend code works of the Matlab. So this is the Matlab code in which I have written getting the value of humidity and computing the average. And after the average has been computed, this Matlab code writes the average value to the resultant channel that has been named as result channel. In this channel, outputs have been stored. What I'm storing is that average value of humidity. If the average value exceeds 60, the value becomes 100. So if the value is 100, my red LED will glow up, and if it's less than 60, then the green LED will light up. So this was the overview of how my Raspberry Pi communicates to the cloud and sends the data. Now that's the algorithm pseudocode The first of all, I'm importing some libraries for sensors and ThingSpeak, initializing GPI pins and initializing some ThingSpeak channels. Then in the main loop, I'm reading the sensor value, sending the data to channel 1, receiving the resultant data, that is average value of humidity, from channel number 2, checking if the average humidity is greater than 60%, then red LED will light up, green LED will go down low, else the red LED status is low and green LED sets to high. That's this code screenshots. The limitation of the project is that there's a transmission delay of 10 seconds because I'm using ThingSpeak, so that's the, you can say, a limitation to that. Not auto starting of the program, I have to first power on the Raspberry Pi and then click on the run button of the program to making the program work. The power consumption is 5 to 7 watts. The future work is that first of all selecting the paid package of the Firebase so that the transmission delay has been catered for, transferring the program to auto start routine so to make the program handy to work, using Raspberry Pi Zero for low power consumption. So that's my system can be used with the batteries. Thank you.